All right, we'll go ahead and get started. Hey, everyone. Thanks for coming. Welcome to KotlinConf 2026. My name is Dan Kim. And today we're going to be talking about how to build a full-stack web application with one important missing piece, which was Wasm. So let's get into it. So last year, I was here talking about something very similar. And I kind of posed this question where I was wondering to myself, like, how do I build a web app in 2025? And I was kind of bemoaning the state of front-end tools. I was like, I don't want to really learn JavaScript. I don't want to build on a huge framework. I just kind of had this like side project idea, and I wanted to build it myself. And of course, the language of choice for me, and probably for many of you, is Kotlin. So I was kind of like musing, how do I do this? I don't want anything like super heavy and big. I just want to do something lightweight. And so all the components that kind of go into it were, of course, like you have to have a database layer. So last year I used Postgres. We have Exposed as sort of like our ORM layer to help us talk to the database. Coroutines was sort of our async library, sort of way to do asynchronous work. And then I had this third-party library called Vaadin and Vaadin Boot, which is sort of the UI layer of stuff. And it was this really wonderful sort of component library that helps you build UI using Kotlin. And overall, it was pretty solid. Like, I was pretty happy with it. It was stable, it was fast, it was easy to work with. But engineers are going to engineer, right? And so some stuff was like a little clunkier than I had hoped. And most of it was around the UI element of that project. Vaadin is a great framework, and it does a lot of wonderful things and gives you this component library to work with. But it is very imperative in its nature, right? So you have to sort of tell it to exactly what to do with your views. And so if you've ever worked with Android, it's kind of similar to that. Or Android views, you had to kind of like just tell it exactly what to do. And it wasn't declarative in any way. And as a result, right, there was, as a corollary, there wasn't really a reactive way of building UI. And so I had to sort of like, I had to build this like custom observable kind of thing and kind of watch for data changes and then update the state. And it was kind of clunky, and it was a little bit more verbose than it needed to be, and it had like these hoops that I didn't really love doing. The rest of the stack was pretty good, but that part was like, I wish I could do it a little bit better. And so even last year, here's me, sort of musing about like, oh man, I hope in a year we can do a similar talk like this, but do it in Compose, right? And I was like really hoping that would be the case. And so our wonderful friends at JetBrains were like, yeah, we can do that for you, Dan. We can totally make Wasm work for you within a year. They didn't actually say this, but this is a sentiment. And so, yeah, Wasm is in beta now. I think it was in September of last year. They made it. They moved it from alpha to beta. And so it is supported by all modern browsers. That means you get Material 3 components you can use. You can use adaptive layouts. You get full animation support, browser integration, like all the sort of things you would need. So that means we can get into what Wasm is, and we can talk about what we can do in 2026. Before I get into how we're going to build it, we should probably take a quick pause and talk about Wasm just a bit. I assume most of you are here because you're interested in it or know something about it, but in case you don't, very quickly, Wasm is basically WebAssembly and is a binary format that runs inside the browser sandbox. So basically, any UI code that you write runs more or less at native speed in the browser, and you don't need JavaScript, you don't need to manipulate the DOM, you don't need a translation layer. It just runs as like a binary application inside of the browser. Again, no DOM. It draws directly to the HTML canvas element, and it does that using Skia. So you have full control over the rendering, and it does it consistently. So you don't necessarily have any issues between browser to browser. It's writing every pixel the same way, regardless of the browser. So you have full control over this rendering. So there's a lot of real benefits to doing stuff in Wasm. That's really brief. If you want to know a little bit more, Pamela did a talk last year. She did a lightning talk where she kind of went into a little bit more detail about it. This is a good talk to kind of get up to speed on what Wasm is, in case you don't know. So the question becomes then, how do I actually build a Kotlin web app in 2026? Right? So the architecture is actually very similar with a couple notable changes. So of course we have database. This year, instead of Postgres, I decided to use SQLite, just a little bit faster, a little bit easier, a little bit simpler, no big deal. JetBrains Exposed is still going to be our ORM layer that helps us talk to the database. Coroutines are still a core component of how we do any asynchronous work. In fact, it has an even deeper cut into the rest of the stack. And then we have two new friends joining us this year. Ktor will be joining us. and Compose Multiplatform will be joining. So we're going to sort of do a similar project, but we're going to focus on a lot of the server and UI stuff. OK, so let's build something. So we are going to build a demo to-do app, and there are some goals and non-goals about that. First of all, what I want to sort of accomplish and what I want you to take away from this is that I just want you to see what's possible with the lightweight, unified tools that basically JetBrains has created for us, right? These tools and frameworks are really nice, and they work really well with each other. So I just want you to have a broad sense of what they can do. We're not going to go like super deep on each one, just given time constraints. But you should have an idea leaving here of like, oh, I could hook all of this architecture up and start working on something. I want you to get excited about Wasm. Like, it is a cool technology. It is still kind of early days, and we'll talk about some of the caveats and stuff like that. But it is a really cool technology, and it can enable us to do stuff that we weren't able to do before on the UI stuff. So I want to get you excited about that. And I want you to start thinking about, like, what can you build? You can build stuff either for yourself, personal projects. Maybe there's some small thing you can build at work that would translate nicely to, like, I just need a small service and a small UI to build. I want you to start thinking about that stuff as well. So how are we going to do that? Well, it's going to be a purposely small code base and surface area, right? Like a to-do app, which is a well-known domain, can go really deep and broadly. This is going to be kind of surface level. It's going to be purposely small because I want you to just understand the concepts and ideas and see how it works. There's all these features I just didn't do just because it would be more time and effort. So it's really just like this core feature of like a list of to-dos. It can be a very simple thing. So there's no need to overcomplicate it. And then, as a result of that, the code itself should be easy to follow and understand, right? It should be very straightforward for you to set up a server, set up an API, set up a Wasm app. Proof in the pudding on that is all of the stuff I'm going to show you in actual Kotlin lines is 486 lines. That's it. So obviously, there's configuration files and other stuff. But in actual Kotlin, it's 486 lines to build all of this. So just keep that in mind. It's purposely small. Non-goals, stuff we're not going to talk about much. Tests, yes, you should have them if you productionize. I'm not going to talk about it here. DI, yes, you should have it if you productionize. I'm not going to talk about it here. Zach is doing a talk right now. If you love DI, you should run over there and go watch that talk. Scalable, did I test it for scalability? No, but I think knowing what I know about Ktor and Wasm and everything, it's going to scale relatively well, but I can't prove that to you. And then, again, this is not like production-ready code. This is just something to get you started. OK, let's get into the actual guts of it. So where are you going to start? You're going to start here at kmp.jetbrains.com, and it's going to give you this fun little wizard where you can kind of pick what your multi-platform project is going to be. For our purposes, what you're going to kind of key in on is the web thing right there that says share UI via Compose Multiplatform UI framework. That makes sure that you can target Wasm as your output. And then you're going to pick server as well, which is the Ktor framework that will come out with it. I think this used to be the way to do it, and I think Martin just said there's an IntelliJ plugin now, so like in the last 20 minutes or a half hour, something changed. But this is kind of where you can start. When you do that, when you import that into IntelliJ, you will get sort of 3 modules. I think this also changed too. They said that it's going to be a single module now. But what it was a couple hours ago was you'd get 3 modules out of it. A shared module that has sort of your models and constants, things that would be shared. You have your server module, which has the Ktor backend that's going to serve your API, as well as the Wasm binary itself. And then you're going to have the Compose app, which is the actual UI code. Just like housekeeping, these are the libraries we're going to use and the versions that are being used. No big surprises there. Ktor fit is just, we'll talk about it a little bit, it's just a retrofit-like Ktor version of an API creation. Otherwise, pretty much what you would expect. OK, so code, finally. Let's talk about the model. This is our amazing, tiny little model. So this is basically like domain-wise, like we're making a to-do. It's not particularly complicated, but this is your model, right? It is also going to serve as sort of the data transfer object. Obviously, nothing too crazy here. It's a to-do item. It's got an ID, a string of what it is, and whether it's complete or not. You can get more complicated, right? You can have assignees. You can have comments and all this other stuff. This is just to keep it simple. This is what a to-do item really is. From the database and the expose layer, we're going to be SQLite. Not a lot to say here. It's file-based. It's simple. It's fast. It's lightweight. It's widely supported with JDBC, so you can use it. You could plug in whatever you want, honestly, here. It could be MySQL, Postgres, whatever you feel like. I've chosen to use SQLite. And then exposed, which is an amazingly awesome framework. Maybe one of the more underrated ones, right up there with Ktor. Exposed is a Kotlin first SQL library that JetBrains wrote. And it has, what's kind of interesting about it is that it has two APIs for work with it. You have the sort of DSL that's like SQL-like query building, and you can sort of chain query items together. Or it has a sort of DAO traditional ORM object style, which is like more like Hibernate or Room or things like that you'd be sort of more familiar with. I like the DSL version of it a lot. I'm going to show the DAO version mostly for simplicity, but it's really interesting that it has this, and I'll show you some comparisons in just a bit. No big surprise, it wraps JDBC, so it works with any JDBC-supported database. Your schema definition, your migrations, your transactions, everything is Kotlin. So there's no odd configurations. You don't have to look in multiple places. You just read Kotlin, and you're good to go. And there's no annotation processing, no code gen. It's not doing a bunch of stuff like behind the scenes. It's just Kotlin, so it's easy to understand. And that's kind of what makes it great, right? There's not a lot of magic. It is pretty explicit, which is to say, like, if you've worked with some other ORMs, there's like code gen, and it like makes a weird relationship that you didn't expect or whatever. So there's no lazy loading. There's no proxy objects. There's no relationships you didn't expect. Like none of that stuff that makes it surprising. It's just you just write Kotlin, and it does what it says it's going to do, which is a good thing. Your Kotlin classes serve as your schema, so whatever objects you defined as the tables and as the properties in those tables is all in Kotlin. So tables are objects and columns are properties. And then again, you have this flexibility in style. You can write it like DSL in the DSL, which reads more like natural SQL, and then the DAO reads more like sort of object-oriented. So you have your choice in tools. And then again, zero annotation, no code gen, so it's just Kotlin. Okay, and so like the way I like to summarize it is like, Expose doesn't really like try to hide away the database. It knows you have to work with it, but what it does is it makes it just like a little more pleasant to work with so that it's a little bit more enjoyable. You're just writing idiomatic Kotlin. So you don't want to like, you don't have to be a SQL expert or anything like that. You don't need to be a database expert. But if you can write idiomatic Kotlin, like you're good to go with Expose. And I think that's really, really important. Okay, so here is the schema. Yes, very complicated. I know, it's like models are model, but the object to do items is our table, right? And it extends off of int ID table, which is basically like it's an ID table. It has auto increment, uses an integer as an ID, nothing too special there. And then we just have three fields, right? Title, whether it's done, and created at. So again, purposely simple. I'm not showing any relationship. We're not doing any relationships or anything like that in the app itself. However, like if you wanted to do it, it's trivial. Like if we wanted to do like an assignee thing, we can have an assignee field that references the users table. You have a separate users table that is an int ID table again, and then it has a couple properties. So like mapping relationships in the schema is very easy and very clear, right? Again, no like XML files, no weird annotations, just objects, properties, easy peasy. In terms of initting the database, nothing too wild here either. I'm just going to create a data directory, and then we're going to connect using Expose connector, using JDBC path and the SQLite JDBC connector. And then in a transaction, we're going to do the schema utils create, which is basically going to create the table. There are going to be more complex scenarios, of course, but generally what this does is if the table's there, then it'll just leave it alone. If it's not, it'll update, or if it's not, it'll create itself. Okay, so I just want to kind of quickly show you like what the DAO sort of interface looks like. We're going to primarily be showing this throughout the rest of the talk, so this is kind of what it looks like. This is the entity object that you have to create if you want to use the DAO style of writing Expose queries. And so sort of the major thing to know here is that it's like, you see the property delegation by each of the, like the title, the done, created at. That's just delegating using the by keyword over to the entity object that I just showed you. And then the companion object, the int entity class thing, is doing most of the heavy lifting. That gives you the whole query API to do like find, where, delete, all those kinds of things. So that does all the heavy lifting. And then the to-do item is just a little helper to map it back to the DTO. But this is a simple example, but the companion object here is, the key is that the companion object is doing most of the heavy lifting for you. One thing I did sort of write, and in most cases you would have something like this, is that I wrote a little suspend function to wrap everything in a transaction. So typically you would obviously wrap everything in a transaction. So this is just a little helper method you'll see peppered throughout. And all it's doing is fairly straightforward if you're familiar with coroutines. We're just going on to the IO thread, and then we're going to suspend the transaction. So everything is like naturally suspends and uses coroutines and exposed, and then you're just going to run the block. So whatever query you run, whatever update statement you run is always going to operate within a transaction. It will automatically suspend, and it will always do it on the IO thread. So there's just a little helper to wrap around that. But this is how you should be running your queries. So this is what like a sample query would look like. This is a very simple thing, but like if you wanted to just get all of the to-dos, this is what the entity version of that, the DAO version of that would be. You just wrap it in DB query. You say, just give me all of them, order them, and map them. Very straightforward, no surprises. Even if you had like relationships and other things here, it would pull back all the things that you would expect. And expose as logging is great. It just shows you the SQL that it writes. There's no, you don't see a bunch of objects flying by. It just shows you the SQL, so you can always debug it very easily. And like you can see here, the order by sort of syntax, where it's just created at to, sort, order, descending. Again, very easy to read, right? There's no sort of surprises about it. If you wanted to do the DSL version, like this is what it looks like. This is a trivial example, so maybe it doesn't show it great, but you can see it's basically, it's not materially different. The biggest thing though is like, if you're more familiar with SQL and you want to have a more SQL-like experience, the select all kind of reads more nicely, right? Like, so if you want to know exactly kind of like what it's doing, select all tells you exactly what it's doing. And so again, like I kind of like the DSL version, but your mileage may vary. Here's a complex query. So if you had to do something like a little bit more involved, here's the entity version of it, right? So you do a find, and then wrapped within that find, you're going to have a couple conditions, like just find the ones that are the ones that are incomplete, and the ones that have the word Kotlin in it. And then we just chain together the order by and then the mapping. So again, it's like very straightforward. It's like I'm kind of beating a dead horse here, but the fact that it's simple and it's easy and you're just chaining methods together is what makes it powerful and really, really interesting. This is kind of where I think, like, as you do more complex queries, this is where I think the DSL version is more effective, or can be more effective. So again, you say select all, but then your where statements are kind of chained, so it's a little clearer. It's not inside that find block, just for me personally. So you're doing a where to-do items is false, or to-do items done is false, and where, right? It reads very clearly. You can see in your brain like how we would write the SQL, and that's worth something if you are familiar with SQL. If you want to do the easier version, though, it's there for you as well. OK, so that's sort of database expose layer. That's sort of the bottom two layers. We're going to get over to the server, get moving. So Ktor is going to serve as our server. Ktor is a HTTP framework from JetBrains. It's like technically acts as a server most of the time. It is, I guess, technically not a server. It is an HTTP framework where it can ingest responses, send it through like Netty or Jetty, and then do something with it. It's coroutine native, so every handler, everything that comes in and everything you do with it is a suspend function. And it's extensible, so you can add these plugins to it to kind of do a variety of things that you want, right? So there's authorization, serialization, cores, compression, all sorts of stuff. So they have all these plugins that you can apply to it. Similar story here, no reflection, no annotation processing, so it's fast and lightweight. So why is it cool? Again, like there's sort of a theme here you might be seeing. It's explicit. There's no magic. It doesn't load up a bunch of stuff you're not sure about. You don't have to. It doesn't even have really sensible defaults. It's just like it has nothing until you put stuff in it. So you got to tell it what to do. And the cool part of that is that, whoops. The cool part of that is that you only install what you need, right? Like not everything under the sun. So other frameworks will give you like 500 features and like all this stuff, and it has to load up and boot. Here you just pick like, I only need cores, authentication, whatever, a serialization. You just pick the stuff that you need, and that's all you get. So there's a wide variety of plugins. I mentioned some of them. Some of the other ones that you might be interested in, WebSockets. There's open telemetry support, open API support that we saw earlier today. So there's a bunch of stuff you can plug in. And if there isn't one, there is an API to create your own, because you are just taking in the sort of raw request, and then you can manipulate it however you want, and then spit it out however you want. And again, because it's lightweight, it starts a millisecond, it's super small. And the reason it can do that is not doing any like super deep annotation processing or reflection or anything like that. It just goes. OK, so here's how you initialize Ktor. There's a lot of stuff here. We'll kind of break it down. The kind of key thing here is that your module, that dot module, is you're just extending off of the application class. So your whole server is just an extension function, right? So that's everything that we're going to be doing in this application. So we'll go through kind of each little step of it. The first step is to install cores. This is not particularly mind-blowing. It's just basically you have to allow cross-origin resource sharing. So these are the methods we're going to allow. Content negotiation, so we're going to basically install the serialization plugin, which allows us to serialize objects and basically send them back and forth from the API. That's all that this is doing. And then routing. Like, routing is sort of like, you know, the bread and butter of like what you would need to do. So basically, we're going to have sort of two sets of routes. One is the first static files route. So this is pointing to the development executable. Basically, what this is the Ktor is going to serve on port 8080 by default, the Wasm app. So it's going to serve out that thing. And then also, it's going to be our API. So there's going to be get, post, put, and delete routes for the API that the client app will connect to. So Ktor doing all of the sort of server work, both for serving the client, but also serving the API. The API surface is not particularly surprising. You can get all to-dos, you can post to them, you can put, and you can delete. So nothing too crazy. The request contracts, like these are just so you know that they're there, but this is how we're going to communicate from the client over to the Ktor app. So basically, we have, if you're creating a to-do, we're going to pass a title. Obviously, if there was more stuff, this request would be a little bit bigger. And then the update to-do request is just whether it's done or not, and then optionally if you want to change the value. Nothing super surprising here. It's just a contract between the client and the server. OK, so let's talk about the endpoints a little bit. This is what they look like. And they're very small, and they're very easy. So when you go to the get route, when you go to the get routing inside the Ktor server, this is what it's going to do, right? It's going to get all of the server. It's going to get all the to-dos. So it's very easy. Val to-dos, you're going to get a DB query. You're going to get all the entities, or all the to-do item entities. You're going to order them. You're going to map them to the DTO, and then you're going to send them back. And they're automatically going to serialize, and then your client is happy. Not too tough. Posts. Again, nothing too crazy here. The only thing that's like a little bit different from a get is that you're taking the call, the HTTP call that's coming in, and you're going to take the to-do request so that you have the request information. And then you're going to wrap it in DB query, and you're going to go into creating the new item, the .new, and you're going to give it the information from the request. And guess what? You're going to respond with a created HTTP response, and you're going to pass back the to-do. Pretty straightforward. I'm not going to go too deep in these because I think they're relatively straightforward. But just to prove that they exist. The post query, I just wanted to show you just like the other version of it. Like if you wanted to do the DSL one, just so you have like the comparison. In this particular example, it's like kind of trivial because it basically looks the same. But again, like if you're familiar with SQL, saying new versus insert, you know, it's worth something just so you know exactly what it's doing. Otherwise, it's basically doing the same thing. All right, put. Same difference, getting a little repetitive. But in this case, the only difference here is that we're getting just the ID, right, instead of a request. So from the call, you're going to reach into the parameters, and you're going to get the ID parameter, and then you're going to go through your body of calling the update request to the database. And then if it's updatable, you'll get a response. If not, you'll just get a null. And then finally, delete. It's very similar to put. You're going to get the parameters of the ID, and then you're going to do the deletion, and then pass back your response. Just for completeness, I wanted to show you all this stuff, but you get the general pattern. Again, like just to show you the comparison between the DAO version and the DSL version of it. Again, delete where, maybe a little bit clearer, up to you. OK. So we have the API running, and we want to talk about the actual client API, right? So now we've kind of figured out everything on the server side. We're going to do everything on the client side, right? And the first thing to set up on the client side is like, how do we connect to the API so we can get data? Just as a reminder, these are our routes. These are our request contracts. And this is what the API sort of like setup looks like. So Ktor Fit, I'm not super familiar with this project. However, it's well used and well regarded, and is kind of an ode to retrofit. So it's like a KMP version of retrofit, and the shape of it, the style of it is all very similar. That's why I picked it, because I love retrofit. So none of this is like particularly shocking if you've used retrofit. But if you haven't, like it's basically an interface, and it will code gen the API for you. You just set up the paths of what you're going to do, and you say what it's going to return. You just set up the basic interface. This is not it's fairly boilerplate in terms of like what you want it to do. So the get is not particularly surprising. There's a little bit of differences for each one in terms of creating and updating and deleting. But the basic gist of it all is like if you follow the patterns of the interface, it's very easy, and then it generates all the API stuff that you can concretely call. This is how you set up the actual client API client on the client. So we're going to create a to-do API object. We're using this method called remember to-do API because we need to remember it between compositions. And this is just how you set up. This is a sort of boilerplate again. Like this is how you set up Ktor fit so that you have a handle to the API. There's a little note there, the client, the HTTP client. That HTTP client is a HTTP client provided by Ktor. So that's why I said earlier, like Ktor technically like serves as a server, but it has client elements to it. So this HTTP client is technically part of Ktor, and you don't really need to go through most of it. It's just basically like it serializes. It is an HTTP client, and it allows you to make the connection to the API. Okay, quick sidebar on coroutines. Like I think it's important to note that like everything here is like built on coroutines. The whole stack is just basically coroutines. So the first thing was like the exposed DB bridge. Like obviously that runs in coroutines. It kicks off into the IO thread and then suspends itself and runs a database transaction. Ktor route handling is all suspend functions. Like when you look underneath it all, what it's doing is it's using this routing context. Everything is suspending like automatically by itself. The API interface that we're doing through Ktor fit uses suspension, so it automatically suspends itself. And then the API calls that we make, we launch them within a scope, and then they will suspend all those things that we call it. So everything is like coroutines top to bottom, and while it's not like explicitly called out, it is sort of implicit in all the things you do, and it's really nice because then you have sort of a very simple, direct mechanism for doing everything async. Okay, I think I've burned enough time on all the boring stuff. Let's talk about Wasm. So this was a slide earlier about like what Wasm is, just as a little reminder. But let's talk about like why Wasm is great. Because you can write web UI with Kotlin. That's the first most important thing. The second thing's total CSS that you have to write, literally 0. Total JavaScript you have to write, literally 0. It runs at near native speed since it's just a compiled binary. And then it renders, since it renders through the Skia engine, it's basically rendering pixels, which means it should be pixel perfect in every browser, regardless of OS, right? Because it's just writing pixels. This is pretty compelling, right? Like if you've ever written CSS or written JavaScript, just using modifiers and all the stuff that we like about Compose is like pretty awesome. Here's a really cool wireframe that I made that's gonna show us like roughly what our app is gonna look like. So this is just it's just a title and some counts at the top and then like an add button. Again, I'm not doing every feature under the sun, and then the list of to-do items. We'll have like a simple dialog to add a to-do, and then we'll have a simple dialog to edit a to-do, and then you can delete stuff as you go as well. Okay, so let's talk about bootstrapping Wasm. This is all it takes to sort of have a Wasm app targeted for your app. So you basically have a main method. The compose viewport hands the browser viewport to the compose runtime and then takes care of it from there. This is the only, I think, browser-specific code in the entire project, right? Everything else is just going to be like UI specific. And so the compiler itself will turn this into Wasm bytecode, and then the native browser will execute that bytecode. Here's the app container. This is sort of like the app itself, if you will. So I just call it to-do app. There's a lot to look at here. I'll kind of get into each section. So the app container itself has like all of the mutable state of the application, right? It is, because our app is just a single screen app, all of the state is contained here. Typically what you would have is like the state of that screen would just be contained here, but since our app is one screen, this is where all the app state lives. So all mutable state lives here. The remembers, if you're not like super familiar with Compose, remembers basically solve the problem of remembering. So Compose is constantly recomposing itself and rewriting the UI. So the stuff that you want to be stateful and not forgotten, you have remember statements for everything. And it's just the to-dos, whether we're adding to-dos, editing, the state of the list, stuff like that. It's all just state stuff. We also create the API hook from earlier so that we can call the API. Sort of the like maybe thing to call out here is this launch effect. So the only thing that's happening is here is when the composition first launches, one time in this case, we're going to go get all the to-dos, and then it's going to be able to use all that stuff. Every other subsequent get for that is going to be done through the other stuff where we add or edit or delete a to-do. So this is the only time that this guy is going to run. If you kind of work your way down the screen, like this is basically the UI at this point, right? This to-do screen is all the UI code itself, none of the state. So the sort of the important thing to remember here is that the state flows down to the to-do screen from the to-do app, and then events flow back up through the Lambda. So the to-do app decides what to do. The to-do screen only knows how to render, right? So we have these very clean, segmented lines of responsibility. I'm not going to go through like every line of the to-do app. The sort of important parts of the UI is going to be the header, which is just like there's an image and a couple other things in the add button up there. I'm not going to go into that. It's pretty trivial. You can look at the code on GitHub. And then we're going to kind of focus on the list itself, which has all the to-dos and all the state and things you can do with it. So just a reminder, this is the awesome UI that we're going to build. So this is the list. And the important thing here is lazy column. So lazy column is, if you've, again, worked with Android, it's like the compose equivalent of recycler view. It only renders the stuff that is in view. So this should feel pretty familiar if you've ever worked on Android. And then like the main thing to remember here is that that key equals it or it.id. That is basically the stable key that preserves the animation and the scroll position and everything like that. That's the key that tells the list like kind of what the current state of affairs is. And then everything else that's passed in the toggle, edit, delete, those are just lambdas that were passed down from the main application. And we'll get into those in a sec. The to-do row itself is the actual row item. That does most of the heavy lifting for the list. Not anything too wild here. It's pretty straightforward compose. All the interactions are passed into the row so that the UI, or so that this method is just focused on creating its UI. And when it's all done, this is what you get. You get the lovely Material 3 purple color scheme. Perfectly rendered, looks beautiful, it's great. If we go to my little movie here, you can see like smooth scrolling, hovers work, like that's it. We like wrote all that. Yeah, I gotta show you like the API and how it calls the API and all that stuff, but like that stuff, that's it. That's all we have, and we've already have all this UI. Like that's pretty great to have Wasm just like go and it's there. So really quickly, I'm going to kind of blow through connecting some of the other actions, which is like adding, deleting, updating. They're kind of repetitive. It's a pattern, but I just want to show you because they're there. So adding it to do, once again, amazing wireframe. So the key thing here is that we have this adding to do variable, this remember. So basically, it's just a stateful variable that just says, are we currently adding it to do? Once we set that, and then the app recomposes itself, then it'll be like, oh, we're in an adding to-do state, and then it will show the to-do dialog, right? This is the beauty of declarative UI. That add to-do dialog is nothing special, so I'll just kind of show you it quickly. But obviously, on dismiss, you're just going to reset that to-do flag again, basically, and say it's false, and then it will recompose itself. And then when you're adding it, on the actual on-add, you're going to set the adding to-do to false so that the state clears itself up. And then you're going to launch the context scope that we have, and then you're going to go create the to-do. You're going to reset the to-dos so that the list knows to recompose all the new to-dos. And then you're going to scroll to the top, which I didn't show, but is trivial. Right? Very easy. The dialog itself uses this to-do input dialog. So what this is just a very terrible slide, but it's an abstraction of just an input dialog because we use it on the edit screen too. And this is kind of what we get, right? So we got this little add. Once you hit add, you get a dialog. It composes itself. You don't have to do anything special. You fill it out, and then it goes. So this is kind of what it looks like in action. You notice snappy, fast, like it's very simple, and it was, I don't know, like maybe 30 lines of code. Editing works very similarly. Here's my wireframe. The to-do list itself, here's the other option, right? So it's like where we had adding flag before. This is going to be an editing to-do flag, and we're going to say which to-do we're going to edit, and then the state, again, will recompose, and then you'll be able to go through and do an edit. The edit dialog leans on the input dialog that I showed you, but it's very similar. You're passing the to-do, so it knows which one to render. You have a dismiss function, and then on update, what is it going to do? It's going to go launch a coroutine, or it's going to use the scope that we have already. It's going to go update the to-do, and then it's going to go get all the to-dos again. Once it has all the to-dos, automatically recomposes. You're done. Like it's so So Compose makes this so easy. It's almost trivial, and that's why last year's were like a little harder. And again, like it just leans on the input dialog, like just like the add does. So editing is just like this, right? You click the actual item itself. What happened? There we go. You click the item itself. You can change the content of it. I could also toggle it if I wanted on and off. I'm going to change, say bye to everybody at CollinConf. Cry emoji, update, and then it immediately updates, right? Like that's in real time. I'm not like faking anything. Like it's just fast. It's easy. Toggling, I'm just going to blow through this. Like toggling is the same thing. It's an update call, except it just happens to be a different interface. There's a checkbox. Of course, it has an action on it. Then you're going to call toggle from the to-do app code itself. It's going to pass that into the list. It's going to do an update to-do, and the only thing that's going to change in the request is its done state. It's not going to change the title. Otherwise, it's the same mechanism as updating. Here's proving to you that it actually will toggle itself on and off. And then deleting a to-do is also very similar, right? You have the delete button at the end of it. The function is passed into it. Here's what the delete call looks like. Oops, sorry, I blew through that kind of quick. Here's what the delete call looks like. Again, you're just in a coroutine. You're going to call to-do or delete the to-do by the ID. You're just going to refresh the list. Automatically goes. So I'm kind of trivializing like how easy and fast this is, but like I want to reinforce like how easy it is really to work with. So here's what the delete stuff looks like once you do it. And again, the key thing here is easy, fast, barely any lag. So the point here is like, again, all of that, everything from connecting to the database to expose, all the database stuff, all the UI we created, all the API connections, everything was 486 lines of code. Like that's pretty great. Like that's a trivially sized PR if you were to push that out for someone to look at. But it did like occur to me there was kind of like one other thing that was nagging at me, which is like we are using Compose, and so like technically it's Compose multi-platform. So like, hey, we should probably be able to do this on other platforms, right? Like I actually wasn't sure if this would be possible. Turns out it should be pretty possible. So this is what the Wasm bootstrap looks like, right? We talked about earlier, like this is the only browser-specific code that you had to write. The to-do app, as we saw, is just a bunch of UI code. So let's say like we wanted to do that for desktop. Like what would it take? This is all you have to do, right? You create a separate entry point, a separate bootstrap. You create a window with some parameters that you want. There's other parameters you can add here, but this is the only ones that I added. And then you just call the to-do app. I literally made no other changes to the code base other than adding this and then running this. And you get a full-featured desktop application. Literally no other changes to the code. Right, here's the add, and here's the add, here's the update state. No changes. So I'm like, all right, well, we should be able to do this on Android, right? Like technically, it's the same code. So here's the bootstrap for Android. A little bit more involved, right? You have your main activity that extends off a component activity. You have your typical onCreate. You're setting the content inside of a box, basically, and then doing the to-do app. There's one other nuance here where I had to give it a URL because this is Android's default loopback, I guess. But otherwise, like again, this is the only code change you have to make. Now, to get to Android, you do have to make some Gradle changes and some build stuff, so I'm not going to over-trivialize that. However, like code-wise, this is all you need. And again, no changes. I didn't change any widths. I didn't change any interaction. I didn't change anything. Like, all this stuff is here. All right, so then the last one, we're like, oh, we can do this on iOS, right? Probably. Yeah, you can. This is all you need on the Kotlin side of stuff. So you just extend Compose UI view controller, and you do to-do app. Again, you're just calling the same UI, or you're calling the same application. This is the iOS bootstrapping. Looks like Greek to me. I don't know. It looks mostly it seems to work. I can't speak to this like too well. But if you look at it, it's fairly simple, right? It's calling a content view, and then it's calling the main KT class and calling main view, which is the function that we just created in the previous slide. So it's not doing a ton. Now, to be fair, like if you're going to create like a bunch of different screens, there's probably more involved. However, just to get a simple application running, this is it. This is all you need on the Swift, on the Xcode sort of side of things. iOS app, like no changes to the Kotlin code other than just making that initial bootstrap hook. So that's it, like 4 apps, 486 lines of code, like that's pretty good. Okay, so let's wrap up. What do we want to take away from this? JetBrains makes a whole suite of really lovely tools that work well together is kind of like the takeaway. All the stuff we wrote is all basically JetBrains libraries. They all work really well together. They have a sort of overarching theme. Everything is consistently and uniformly architected, right? Like you know how it's going to work. They all use coroutines. You know what to expect. There's no surprises. Everything is like, not everything, but like they're basically like lightweight alternatives to these to-do everything frameworks, right? Like if you have, an ORM that can do everything under the sun, or a server that can do everything under the sun, and you need all that stuff, that's great. But if you just kind of want to like spike something, get something up quick, and have it be really fast and easy to reason about, these are great choices. And ultimately, it just enables you to do development at all levels of the stack, just using idiomatic Kotlin, which is like the dream. Okay, there's some caveats I got to talk about. So Wasm does render to a canvas, right? So by default, you're not writing to DOM. You're not writing to the DOM, right? So there's no accessibility layer. There's no copy-paste. There's some weird stuff, right? It's kind of early days for Wasm a little bit, just as a standard. So that's something to keep in mind. There are workarounds for that. There's ways to write to the DOM for anything that you want to be accessible, so that you have people with, like if the low vision people can see, can use accessibility readers and stuff. So there are ways to do that, but there is a little extra work to doing it. And it's still kind of early days. I'm not an expert in that, but that's definitely something to keep in mind. Scrolling is pretty good. I wasn't able to see like a ton of problems, but occasionally you might see some jank. So it's just early. It's not terrible, but it's just something to be aware of. And debugging is like kind of tricky. I didn't get into this a ton. But again, you don't have view source, you don't have a DOM, so you can't really get in there and like change things around and like do it. You have to kind of do it, build it. There is hot reload, so it can get going fast, but it's a little bit tricky. So you got to kind of rely on print lines. Stack traces are kind of cryptic. These are some things to keep in mind. Mobile. So yeah, there's a little bit more boilerplate than your setup. So building for multi-platform, there is more build stuff. Actual lines of code is not alive, but there's some extra build stuff. For Android, you're going to want to follow some patterns. I did not to do anything here. And for iOS, there's more harness code to get integrated with Xcode, the stuff that I showed you. But just in the simple cases, it's not a ton. But it is something to be aware of. So ultimately, like this slide, I kind of lied about it, right? It wasn't everything else. It was like the platform-specific code was 38 lines. Everything else was shared UI, the server, the API, all the database stuff. So I just want to kind of leave you with this, which is like, you can do quite a bit with Kotlin now, right? Like you can basically do everything you want in Kotlin. And so there's a great opportunity to kind of be on, in particular on the Wasm stuff, to be on sort of the bleeding edge of stuff. So I would encourage you to play with that. I really would encourage you to go build something for yourself. And I would really encourage you to like try to find somebody to do it with. Like, it is a weird time in the world right now. There's a lot of tools that are being talked about. KotlinConf is an excellent place to meet people who are like-minded, who enjoy the same things as you. Go build something with another human, collaborate. It's a lot of fun. All the code is going to be up here. You can go get to it now. And I hope you have a wonderful KotlinConf. Thank you.